Assalamualaikum and very good morning. My name is Nurishma and right now I'm going to present about my thermodynamic project for thermodynamic 1. So let's go to the introduction. Okay, for this project I choose kilang sawit pancing VA4053 is for the power plant. Okay, then the branches of the Felda Pump Industry Sungai Berhad. Okay, it is located in Felda Sungai Pancing Utara, Bukit Kuala Kuantan, Pahang. Okay, that's for introduction for the company. And then let's go to the topic. The main purpose of going there to obtain the report about the net power output, the type and amount of fuels, the power consumed by the pump, fan and other auxiliary equipment, stack gas losses, temperature at several locations, the rate of rejection at the condenser and the rate of entropy generation. Okay, the main report. In this power plant, they got two steam boiler, which is Vickers Hoskin and Magma, and they use Vickers Hoskin as a steam boiler. And then they got two turbine in here, which is Elliott J. Nadrowski and another one, but they choose the Elliott for the turbine to be used. Okay, here are some of the data that we can obtain from the boiler and the turbine use. Right now, I'm going to present about the data that wanted. Okay, so the net power output used by the produced by the company is 1,800 kilowatt. The type of fuel they use is pump fiber and pump kernel, which is the waste material, because this power plant use biomass power act as a biomass power plant. And then the amount of fuel, there is no amount since they use all the waste material. And then the power consumed by the pump is 900 kilowatt. No other power for fan and auxiliary equipment. So the stack gas losses, okay, stack gas losses are characterized into two categories, which is for temperature and combustion. So in this step, it is defined by the temperature, which is more than 250. Okay, so temperature at several locations, all the temperature is maintained around 90 degrees C. Okay, the rate of heat rejection at the condenser. Since this power plant use an open cycle, so they have no condenser. Okay, the last one is the rate of entropy, which has to be calculated by using formula. So from here we got source and the sink. So source, the data that we have is the temperature, mass flow rate and pressure. So from this data we can obtain some other data from table A5 and A6, such as the saturated temperature. And then we can know the state of the gas or the material at that point. Okay, so we go to the sink. When it is come to the sink part, we only have temperature. So from this, we know that we assume that the volume is the same. So it is in a rigid condition, which is V1 is equals to V2, which is V in source equals to the V in state. So from that we can calculate the X, which is quantity, from state 1 to state 2, state 1 which is in superheated region and state 2 in mixture region. So from that we get X, and from X we can calculate the entropy for second state. So the entropy rate is mass flow rate times with S2 minus S1, so we get negative 92.8098, which is for cooling. So that's all for my presentation today for this report. Thank you.